Good morning, everyone. Our practicals today would be on creating a digital signature using OpenSSL. So, first, OpenSSL is a tool that helps you to implement the SSL and TSL protocol to enhance communication between the sending machine and the receiving machine. Today, our sending machine, I'll be using my Kali Linux, and the receiving machine would be our Parrot OS. To create the digital signature, the signer should follow the following steps. We're going to create a hash value from the message, sign the hash value using a private key, send unencrypted message, the encrypted hash value, and his or her public key to the recipient. So the receiving end, that's my Parrot OS, would follow the following steps to decrypt the message. Verify the digest by decrypting the digest. Then create a one-way hash of the encrypted document or text file. So the receiver will now compare the hashes gotten from step 1 and step 2. So my Kali Linux, I've already started my Kali Linux machine. So the sender has to sign the document using his private key. The sender will generate the private key using the command open SSL so okay, we have to use this cipher block changer to create the private key. If we don't use the cipher, if we don't use this cipher, we won't be able to create this private key. So enter. Okay, the system has requested I put a password, so I'm going to use the password king. Enter, verify the password. I have to LX to check if the file has been created. Okay, you see here the private key has been created. Then I want to create a bank credentials using my name and my ATM pin. The cat bankcred dot bankcred dot txt. Enter. So I'm going to create my name Chimaju, my ATM pin. I'll use 1001. Enter. So now cut bankcred.txt. You can see it showed the file I just created shows my name and my ATM pin. So now I'm going to create a hash for this file using the command open SSL digest, that's the DGST. When you're creating a hash, you have to use dash sha 512. I enter. Now LX to confirm if the file has been created. Like you see here, I've created bankcred.sha512. Um, so now I'm going to sign this document using the command open SSL pky Okay, this command means sign bankred dot sha512 using my private key, then store the output into bankred dot sign. Says sign bankred dot sha512 using my private key which I created initially, then store the document into bankred dot sign. I enter. It will ask me for my password, the password I created, the password I used to create the private key. I put in the password king. Mm, okay, that's fine. Alex, when you see the bankred.sign has been created, that means we've signed the file. So so I'm going to sign this document with my private key, while the receiver will use my public key to decrypt the signature. We need to transfer the public key to the recipient. To extract the public key, I will use the command open SSL RSA in private key, then .pen to request for my password. I'm using the same king. Let me LX to check if the pubkey.pen I created has reflected. So when you see here, I've created pubkey.pen. So using the Parrot OX, which is the recipient, I have to enable the SCP, the SSH protocol. The Parrot OS uses SSH protocol for its operation, so I have to enable SCP on the Parrot OS and also enable SCP on the Linux distro. So I'll enable this first while I go to the Parrot OS. I'll use sudo system control start SSH service. Enter. It will ask for my password. Hash. Okay, I have to go to my Parrot OS now to enable the SSH service on my Parrot OS as well. To enable us transfer these files, that's the Parrot OS as the receiver would be able to receive the files from the Kali Linux. Parrot OS terminal, I would also enable the SSH service on my Parrot terminal. So now I'll go back to my Kali Linux for me to send the signed bank credential to my Parrot OS. So for me to be able to send a document to my Parrot OS, I have to find out the IP of my Parrot OS using the command ifconfig. Enter. So the IP address of my Parrot OS is 192.168.1.85. So this is what I'll be using to send this document. So going back to my Kali Linux, I'll use the command, since we've enabled the SSH service, I'll use the command scp bankred.txt, sorry, bankred.sign. That's the first one we're sending. Then user at my IP address 192.168.1.185 colon slash home slash user. That's my default username for my Parrot OS. I enter to request for my Parrot OS password. I enter. Okay, there's a spelling error here. So I'll use SCP Bancred. Okay, I just corrected it. Then I enter. Put my Parrot OS password. You see, it has sent the file. So the next one we're going to send is okay. Okay, by default, Parrot OS does not allow incoming packets. So in case your system is not allowing the packet, you need to make it accept incoming packets by setting up the firewall. The command to do that is sudo iptable nost filter space then dash vnl. The L is capital. So the next file we're going to send is the bancred.txt. scp bancred.txt, the user the same. Enter. It's requesting for my Parrot OS key. Enter the Parrot OS key. It has sent. You can see the values here. It's sent 100%. The last file we're going to send is the public key. Okay, like you see it, I've inputted it to request for my password. I enter the password and it has sent completely. So the next thing we're going to do is we'll now go to back to the Parrot terminal. So on our Parrot OS, the receiving machine, which is our Parrot OS, wants to confirm if the message sent truly came from our Kali Linux machine. So we'll use the first to LX. This is the documents that was sent from the Kali Linux machine. We'll use the command to verify this. Just follow. So using this pop in command, you're telling the machine that the key I gave you, public key, like you need to verify it, that you're giving him this public key. You're giving the Parrot OS this public key. Okay. Okay, now I have to repeat this command is open SSL. Okay, bancred.sign. Then send the output to Okay, earlier I used a wrong command. I didn't include the output. That's the file is supposed to save this document into. So then I enter. Okay, now we'll LX to check if we've created this document. Okay, when you see here, you see bankcred dot digest. That's what we just created. We're just trying to confirm if the message actually came from the Kali Linux. So the recipient has the hash originally. That's our parent OS. We're just assuming the recipient has the has the hash, the original file bankcred.txt using a hashing algorithm to generate a hash value to check if the message was tampered with while on transit. So we'll use the command open SSL digest. We're trying to check if this message was tampered with while on transit. Um, bank cred.txt to bank cred.digest. Just confirm, and I'll have to ls to check if I've created. Okay. um okay, I'm supposed to specify bank rate too. No, I have to repeat this again. Open ssl digest show to txt, save it into. Okay, like you see here, the command I used earlier was wrong. So you see here, the Bankrate 2 digest has been created. So now we will use the diff linux command to compare if these two files, the Bankrate dot digest and the Bankrate dot Bankrate 2 dot digest, we need to compare if these documents are equal. Like we need to compare the hashes. So using the diff command, diff bankcard dot digest bankcard to digest into. The files bankcard dot digest are identical. Good. Okay, it says the files bankcard.digest and bankcard2.digest are identical. So it means that this the hashes was not, sorry, the document was not tampered with while on transit. This diff command displays the equality of the hashes. Yeah, so we're done with our digital signature creating a digital signature using open ssl. We're done with the practical. You see, it shows us that file bankcred.digest and bankcred2.digest, which we created earlier to decrypt our the file that we sent. It shows that they are identical. So that means it was not tampered with while on transit. If it's not identical, it's going to show you 0 at 1 depending on your system. If it's identical, it will show you 1 C1, which means 1 equals to 1. That means they are identical. The next practical we're going to be having is how to create a digital certificate using OpenSSL. So creating a digital certificate using OpenSSL. First, certificate helps to prove the identity of an entity. Your server is trying to prove its authenticity to your web browser that hey, I'm original, I'm not fake. So digital certificate is like being stopped by a traffic controller official and the request for your driver's license. Once you tender your driver's license, they verify if it was signed by the right authority. So they have to verify all this information. That is how a digital certificate works. So digital certificate helps your web server to verify its identity to your web browser. Digital certificate is being issued by licensed authorities. Examples of these authorities is DigiSat, GoDaddy, Komodo, etc. So in this practical, we'll be creating a self-signed certificate. A self-signed certificate is being used by back-end developers, website designers to verify their website, like to host their website on the Apache server instead of using the original the original digital certificate licensed by an authority like DigiSat. So for these practicals, we have turned on my Kali Linux machine. It's the same process when you're trying to create a a digital signature as well. So what I'll do, Alex first, I have to remove the banquet.sha and all of this banquet.sign because we will be using only the private key.pem and public.pem. So I'll use the command rm as remove banquet.sign, banquet.sha, and banquet.txt. Enter. Alex. Okay, it's been removed. I'll clear the system. So we're using these two key pairs, privkey.pem and the hold on. We're using these two key pairs, privkey.pem and popkey.pem. Okay, first we have created these two key pairs. What we'll do next is we'll create a certificate signing request with the command open SSL request. That's where requesting a new okay. So we're requesting a new certificate using our private key, and we're going to save it as chimaju.csr.csr. So I'm requesting a new certificate signing request using my private key, and they'll save it as Chimaju CSR. It will request for your password. I'll use the password I used to create my private key. If you can remember, we used King. I enter. It will ask me for my country name in two-letter code. That's Nigeria. I'll use Nigeria. NG. To say state or province, I'll say Rivers. Rivers, Rivers State. Locality name, I'll use Port Harcourt. Organization name, I'll use Career X. Organization zonal unit, cyber security. My common name, Chimaju. Next, okay, it's asking for my email address. Create my email address. Enter. Okay, it's asking for me to create a password. I'll still use the same password as King. You can use a stronger password if you wish. Enter optional company name. I'll use my personal company name. Bookingport.com. Okay, so it's been created. So if we are involving a third party like a certificate authority, uh, we need to send the file we created earlier, Chimadu CSR, to them so that they can generate a private key for us. So to confirm if so since we are not doing that, we'll just go ahead because we are creating a self-signed digital certificate. To confirm the informations to confirm the information we just input here, we'll use this command open SSL request text, like we're confirming the text. Text in, enter, and we go up here. See this gibberish thing, you just leave it, go up here. It will show you all the information we just input to confirm it and all that. You see, when you go up here, you see um country, Nigeria, state, River State, locality, Port Harcourt, organization, career X. This is just a command you use to confirm the information, the information you've just inputted. So now we will need to sign our document using the X509 standard. So to do this, we'll use the command open SSL X509. I already typed it earlier. So open SSL S509 in Chimaju CSR.csr, then output to Chimaju certificate.crt. So we'll specify the number of days we want this digital certificate to last for. The number of days we specified is 365 days. Enter. It's prompting for my private key password, which is King. Enter. It says the certificate request self signature. Okay, that means we've created our digital certificate. So to confirm, okay, we've created our digital certificate. So we can install this our self-signed signature into an Apache server. An Apache server is a server pre-installed in every Linux distribution. The Apache web server helps you practice saving files over the internet. Apache makes use of the directory /var /ww /html. So if you are a web developer or a back end or front end developer, you can create a self-signed digital signature just to test if it's working properly. That is the use of self-signed signature. That is what self-signed signature is used for. It is not used for public use alone. It is not used for public use at all. It is only used for private use. Only used in your visual lab or just to test your website for a client. Okay, we won't be doing the practical on how to install this digital signature on Apache because we have a lot to cover. You can DM me privately if you want to learn this. Thank you. So this is all for creating um, a digital certificate, and also for creating a digital for decrypting and encrypting our digital signature. Thank you guys.